In this video, we're going to look at questions 10, 11, and 12. Let's look at 10 first. Just like in 7, 8, and 9, we cannot solve an absolute value equation until all these numbers on the outside here have been eliminated or moved to the other side of the equation. So first I'm going to add 5 on both sides. I got this 4. Now there's this 4 here. We need to divide by 4 on both sides. Whoops, alright, there we go. Divide by 4. Now we have it in the form that we can split into two equations. We have an absolute value by itself in here and a number here. So this says equal. As you remember, absolute values always have a positive and negative answer. So this can all be 1, or all this can be negative 1, because if negative 1 goes in here, if this produces negative 1, then the result through the absolute value will be positive 1. So we have two possibilities, and it's an OR situation. We have this stuff in the middle here can equal 1, or this stuff over here can equal negative 1. Because again, if all of this was replaced by 1, it would still produce a 1. Or if all of this was replaced by negative 1, it would still produce a 1. So here's our two equations. Solve each one. That one, I subtracted 3, then get rid of the negative signs, x equals 2. Or, on this side, subtract the negative 3, get rid of the negative on both sides, x equals 4. We have two possible answers, x equals 2 or x equals 4. And you can check if that's good by plugging it back in. You can put your 2 in here, so negative 2 plus 3 is 1. Great. Put a 4 in there as well. Negative 4 plus 3 is negative 1. It works out. Number 10. Similar kind of question. Instead of an equal sign, we have a greater than or equal to here. Alright, let's get rid of this negative 3 and this 6. So let's subtract 6 first. Subtract 6, you get this. Let's divide by negative 3. Don't forget, when you divide by a negative number and you have an inequality, the inequality will change the way it is facing. So when I divided by negative 3, I got a 5, but this turned into this. Alright, this turned into this. Now we have an absolute value with no numbers on the outside here. We can turn this into two statements because absolute value has a positive and negative. Don't forget, when this is facing away from the absolute value, it means we're looking for x values less than 5, or values less than 5. If you think of values less than 5, they're ones that are from 5 towards the center, towards 0, and then on the negative side, it's always a mirror image. So if we're looking for values less than 5, like 4, 3, 2, 1, then on the negative side, we're looking for negative 4, negative 3, negative 2, negative 1. We're looking for those same numbers, so the only way to produce that is to do this. We have this thing is less than 5, but this thing is greater than negative 5. Again, you're looking at symmetry or a mirror image, and that we're looking for the same numbers between 0 and 5 on this side, and between negative 5 and 0 on this side, so it's a mirror image. Now add 5 on both sides, you get this. Divide by 2 on both sides, you get this. Values of x between 0 and 5 inclusive meet or satisfy this inequality. Oh, and it asks for the answer in interval notation, so there it is. From 0 to 5 inclusive of both, so square bracket. Number 12, we have this one here. Again, we have to get rid of the 8 and the 3 first. So I'm going to add 8 first. Here's 21. Now I'm going to divide by 3. Let's turn to 7. Now we have this. This is the opposite of the last one. Last time the the inequality was facing away from the absolute value. Now the inequality is facing towards the absolute value. So this is saying absolute value is producing numbers that are greater than 7. Think of numbers greater than 7. 8, 9, 10. It's those numbers that are growing beyond 7. Now think of the mirror image on the negative side. So here, on the positive side, we're looking for numbers bigger than 7, so 8, 9, 10. On the negative side, we're going to look for numbers bigger than negative 7, but in the negative direction. So negative 8, negative 9, and so on. So the way to show that is to write OR. Here, we have this statement, greater than 7, okay, so we're looking for numbers greater than 7. Or, on the negative side, we're looking for this thing being less than negative 7. So we're looking for negative 8, negative 9, right? The same thing. It's a mirror image. Imagine that mirror in your head. Numbers greater than 7 and numbers greater in the negative direction than negative 7. Alright. This one, add 4, multiply by 2. This one, add 4, multiply by 2. And we get these two answers. In interval notation, let's make sure we get it right. These are numbers less than negative 6. So they're numbers from negative infinity all the way to negative 6. Those are all the numbers less than negative 6. Union means we have an OR situation. So those numbers, or x can be these numbers, which are numbers where x is greater than 22. So 22 onwards to infinity.